Dear students, I am Dr. A.Nirmala, Assistant Professor, PG Department of Computer Application, St.Joseph College of Arts and Science, Autonomous, Cuddalore 1. In this session, we will discuss about memory management in operating system. Memory management. Memory management is used for allocation, the deallocation of memory. The main function of the OS. The OS only manage to manage the memory. Here, the memory management tells about which process has to be loaded and which process and where it has to be loaded and how is to be loaded. It has to be categorized into two types. One is real memory management, another one is virtual memory management. Real memory management need the whole process to be inside the main memory when it is executed. Virtual memory management is it is enough to store a part of the process inside the main memory. Actually, the difference between the real and virtual memory means in real memory the entire process should be reside inside the main memory means when it is executed it should be real memory management. In virtual memory management, only the part of the process can be reside inside the main memory. In real memory management can be classified into two types: contiguous real memory management and non-contiguous real memory management. Contiguous real memory management can be classified into three types: single contiguous memory management system, fixed partition memory management system, variable partition memory management system. In contiguous real memory management system, the process can be loaded in the main memory contiguously. Non-contiguous memory management system, the process can be loaded in the main memory non-contiguously. The non-contiguous real memory management system can be classified into three types: paging, segmentation, and combined system. In contiguous real memory management system, the first method is single contiguous memory management system. According to the single contiguous memory management system, only one part of the process can be loaded into the main memory. Here, the main memory can be divided into two parts. The first one is OS part, second one is user part. In the OS part, the OS occupy the part in the important portion of the OS can be occupied in the main memory. The user part only, the process can be allowed to be reside inside the main memory only in the user part. If the process entered in the main memory, if the process gets completed, it's swapped out, then only a new process can be swapped in to be get executed. In single contiguous memory management, only one process can be allowed to be reside inside the main memory. So the process which is residing inside the main memory can, after completion, it should be swapped out. Then only the new process can be allowed to be reside inside the main memory. So swapped out and swapped in can be carried out in single contiguous memory management. And the swapped out and swapped in can be explained by the following diagrams. Here, already in user part, in single contiguous, only one process can be reside in the main memory. For example, consider, suppose the process A gets executed in the user part, then it should be swapped out. Then only the next process B will be swapped in. So it will be started to get executed. So in single contiguous memory management, only one process can be allowed to be reside inside the main memory. Advantages of the single contiguous is it is simple, very easy to implement and use. Disadvantage, already we see only only one process can be allowed to be reside inside the main memory. So the main disadvantage is lack of multi-user facility, and then internal fragmentation will be happen. Internal fragmentation means in the user part, suppose you consider the size of the user part main memory is 32K. Our process, the size of the process is 22K. So 10K memory will be main memory will be remain used. The remain used part is called as an internal fragmentation. Then up to till now we recall about how the single contiguous memory management works. Now we will see about how the relocation and address translation will occur. In single contiguous memory management, the starting physical address of the user program is known at the time of compilation itself. The starting address is, if there is less than fence register, means it should be the part of the OS part. If it is the protection bit, if it is greater than the fence register, means it is the part of the user part. So the problem of the relocation and address translation does not exist, because during the compilation time itself we know where the starting address of the main memory, so it is easy to store the program. So no need for the relocation and address translation. Protection and sharing. The single contiguous memory management divided into two parts. One is the OS part, another one is user part. The OS part starting bit is protection bit is assigned as an 0. In between the OS and the user part there will be a fence register that we will assign the protection bit is, for the user part we will assign the protection bit is 1. So the protection bit, if the protection bit is 0, it is the part of the OS. The protection bit is 1, it is part of the user part. If the user tried to access the protection bit is 0, it will be denied, the access will be denied, because the protection bit is 0 means it is only part of the OS part. The user never have rights to access the OS part. Evaluation. Evaluation means here we will evaluate the single contiguous memory management based on the three things. 1. Wastage of memory. 2. Access time. Third one is time complexity. Wastage of memory. Here the wastage of memory is avoided. Sometimes internal fragmentation occur. Even though internal fragmentation is occur, it doesn't affect, because only one process can be allowed to be reside inside the main memory. So if there is any wastage also happen, it doesn't affect. Then access time. Single contiguous memory management has fast access times, because relocation and address translation can be carried out easily. We know very well during the compile time itself, we know very well the program will be, the process, the user part of the process will be stored, starting address is 0. So relocation and address translation can be done easily. So the access time is very fast. Time complexity. In single contiguous memory management, the time complexity is very less. I hope you understand very well about the single contiguous memory management. Thank you.